Since the advent of space exploration, we have gained a new perspective on the globe we call the Earth. Photographs from space show a view of Earth floating in the heavens, white clouds swirling above the oceans and continents. Within this sphere is contained a series of concentric layers. At the center is a solid core surrounded by a dense, bubbling mass of superheated molten rock. We live on the surface, a fragile, shifting crust in places barely 3 miles thick. The Earth's surface is constantly moving. At one time, some 200 million years ago, there was only one vast continent on the Earth, Pangaea. Over millions of years, the land masses have moved and separated and continue to do so today. About 135 million years ago, South America began to drift away from Africa. The Earth's crust consists of rigid plates which are continually shifting position. The plates are moved by convection currents in the molten layer beneath the surface. As the plates separate, usually along the thinner oceanic trenches, molten lava rises from beneath the surface and moves into the gap that is created. The new rock helps push the plates apart, and as it cools, becomes part of the continually regenerating crust. At the other side of the plate, different types of collisions occur with other moving plates. As the ocean plates meet continental plates, they are forced downward. Beneath the surface, friction and pressure force molten rock upward to erupt through the crust as ash and lava. Volcanoes have been formed in this way, strung along the western edge of the North and South American continent. A second type of collision occurs as two continental plates converge. As one plate slides under the other, the lighter mass at the surface thrusts and folds upward, forming some of the world's high mountain chains. The third type of plate interaction occurs where plates meet at oblique angles to each other. Pressure and friction between the surfaces prevent slippage. When the tension becomes too great, the plates shift, sliding along a fault line. Occasionally, violent tremors result and cause the widespread destruction of an earthquake. The Alaskan earthquake of 1964 was caused by such a shift in the fault running along the western edge of North America. The Earth's landscapes have been created over millennia by the gradual shifting of continental plates and by the violent effects of volcanoes and earthquakes. These primitive shapes are in turn worked upon by other natural forces. Frost cracks the mountain rocks. Glacial ice, wind, and water transport rubble into the lowlands. Rivers etch the valleys, carrying small stones to the sea, where, layer upon layer, sand and organic matter is pressed to the ocean floor. These sedimentary layers are changed over time by pressure and heat from deep within the earth. The many different types of sediment are transformed into a vast range of rocks, minerals, and ores. Vegetation becomes the energy wealth of coal, oil, and natural gas. Rock sediment becomes the hard, metamorphic rock that gives us valuable ores and the building materials we prize for their strength and decorative features. The most valued of all the rocks are the gems and semi-precious stones mined from the earth or exposed at the surface by wind and water. The most prized of all is the diamond. As the currents of molten rock force upward and build the rocks that release these precious stones, so too do they force the older layers of sediment downward. Eventually, the sinking rock contacts the enormous heat inside the earth, melts, and returns once again to the cycle of eruption and continent movement that gives form to the planet we live on.